So, as Gail mentioned, I'm Almeroth, Department of English. We've had a fairly strong presence in what we're now calling digital humanities for about 20 years here. What was different back then is that we had no sense of what cohesion held the field back together back then. The field in the humanities, there was influences coming from computers and rhetoric at that time, from media studies, and from linguistics as well. There was no real sense of a single field. What's really happened, there are a lot of resources in my talk. If you want them, they're here. What's really happened in the last 10 years is the formation from the ground up and self-definition of field that everyone is calling digital humanities now. There's some resources here about the transition from this looser aggregate of disciplines in the past to something that everyone is calling digital humanities. The takeaway lesson really is that right now, what's happened is that the digital technologies are being integrated in the mainstream established disciplines and methods of research, whereas in the past with linguistics and media studies, it was coming in sort of in a satellite way from the outside. So a lot is going on right now. You can get a sense of that from the Google Ngram viewer for digital humanities. You see that the takeoff point is roughly around the year 2000. The field firmed up about 2005 on. And the secondary symptom of the fact of that is the fact that we're capitalizing that as if we're a proper noun and how. So there are a lot of writings now in the field that survey and review and critique the digital humanities as a field that's forming. You'll see many of the resources here, overview essays. Some of those are my own. The number of scholars in the digital humanities field has been ballooning, especially at the entry and mid-levels. So there are a lot of universities, such as University of Maryland, College Park, University of Virginia, Stanford University, that have set up programs, training institutes, and digital humanities centers that are pretty much in the business of training a new generation of humanities graduate students who have these kinds of technical interests and expertise. A large number of universities, I'm a little bit scared of this. We got started with this early here, but now this field is being gobbled up by major public university systems like the University of Nebraska system, the University of North Carolina system, and also elite private universities such as Stanford and Yale, who have the big bucks. So they've gotten big bucks and big grants, and they're doing things like cluster hires in the digital humanities field. They've been trying to present a scare message to our dean, saying that we don't want to get leapfrog. We better begin putting some more resources into what we've already established here and are well known for. And the bottom line argument is that increasingly it's making a difference in the job market. So just in the English department, it seems to be the case that the graduate students who have some element of digital methods on their CV are getting the initial nibbles. Doesn't mean necessarily they get the jobs, but an increasing number of them are getting the first look. Because there are a large number of humanities departments in the nation who haven't gotten into the digital game yet and are looking for someone who can help bridge them into this field.
Are all the nibbles from academia?
Most of them are from academia, but the next thing I was going to mention, as a matter of fact, that there are an increasing number of jobs in the so-called out-act field. Have you heard that phrase, alternate academic? So these are kind of hybrid jobs. They're in project management positions, library positions, cultural institution and museum positions, other kinds of positions that aren't tenure track academic, but offer, in some cases, fairly good jobs. So there's some fairly well-known people in the DH field, as we call it, that are in these combined staff / sometimes teaching positions. Bethany Nowitzki at University of Virginia, for example, in their Scholars Lab. Miriam Posner down at UCLA runs one of these positions. Stanford University, every time I go there, the contrast with our funding here at UCSB is just, I want to bow down and look under each blade of grass and see who the donor was at Stanford. They're rich enough that they've had this tradition of staff positions that they're embedded in departments. So these are staff members who assist the English department in leading them to the next frontier in digital humanities. One of the most famous of digital humanities people, Matthew Jockers, was of that sort. They couldn't hold on to it finally. University of Nebraska rated him because they gave him a tenure track job. So awareness of a DH in the profession in general is increasing. The most recent modern language association convention, something like 10% of all sessions had to do with digital humanities. So the field is booming. My definition of digital humanities goes something like this. It's a field that uses digital network information technology, IT, to curate and study humanities materials in literature, history, art, and so on. So right away there, that's a big difference from the previous 10 years. Now the technologies are being integrated into the core activities of these disciplines, which is the curation and the study of these historical materials. Now, the interesting aspect of that is that there's big data involved. Big data in the humanities world is actually small data by science standards. So let's call it meso-level data. But what we lack in terms of sheer size, we make up for in terms of the messiness of the data. So there are serious and interesting computational research problems involved in dealing with historical data, much of which is missing, much of which is in inconsistent form. Very interesting research problematics there. Secondly, however, DH uses information technologies to study the humanities in ways that could not have been done before. So that's the other new thing now. People are approaching humanities in completely different ways. The battles have yet to be fought about the legitimacy of these methods, such as are you going to get tenure or not for producing a database of materials. DH also makes IT itself an object of analysis from a humanistic perspective. So there are a lot of people interested in, for example, the history and theory and cultural practices of the technologies. DH is both theoretical and practical. One of the big controversies in the field is, are you a DHer if you just yak, as opposed to someone who can also hack? So it's a hack versus yak controversy. Most humanists like to just talk about things in one format or another, so now we've got coders and builders involved. Are they going to get tenure? Are they the real future or not? It's yet to be determined. And finally, I just mentioned that DH, unlike most of the other disciplines you'll hear from today, has a critical and artistic side that overlaps with, but it's not quite the same as research. So one of the most vibrant methods in the field now goes by the name of deformance theory. In essence, you disrespect the original structure and themes of a work. You break it, you deform it, and see what new insights you can gain from it. So I'm just going to be very quick and just hit on the most robust frontier areas in the digital humanities field right now. Many of these are borrowings from other fields, and you're going to hear more developed approaches to these in these other fields. The first field I mentioned is text encoding. Among all these methods, probably humanities are best positioned to be experts in this. So this is an example of early writing. This is called scriptural continua, continuous writing. Before the invention of word spacing, capitalization, punctuation, chapter divisions, titles, any kind of metadata at all. That's because at that time, cultures were primarily oral. If you were a monk or a priest, you kind of study this in advance, maybe mark it up, and you rehearse it, because then the real performance is, the actual live sermon. So that's in essence, comparable to a musical score rather than the performance itself. If you think about it, all of the history of writing and of reading from that point on is the invention of structured metadata and markup. So the invention of breaks between words, between sentences, between paragraphs, between chapters, titles, metadata. You get a sense of why, in other words, text encoding is still one of the main areas of research in the humanities. So there are a lot of resources there. Some major humanists, such as Michael Spurberg McQueen, whom I went to graduate school, had a core influence on the development of today's markup languages, such as XML and so on. The flavor of markup language that is most in use in the humanities, as you may know, is TEI, for Text Encoding Initiative guidelines. It's a set of resources designed to allow for the markup of any kind of printed and also manuscripted kinds of materials. So that's a continuing robust research area. You would think that we know everything there is to know about text encoding. But you haven't seen nothing until you've seen Macbeth marked up by the Folger Shakespeare Library down to the level where every single word has a unique identifier in it. At that level of granular markup, you can do things with text you could not have dreamed of doing before. We also have great controversies in the field. The controversy about the ordered hierarchy of content objects model, nested tags. How does that or does that not fit the structure of knowledge in the humanities? That's still an ongoing discussion topic today. Another robust area, of course, is let's say that you don't have texts that are intricately marked up. How do you do something interesting with them analytically? And of course, the big front of research right now is text analyses of all kinds. So this is an example. This particular work by two graduate students, Ryan Huser and Long Lecoq, the analysis of 2,948 British novels from the 18th century. Not huge data, but it's big data for the humanities, and they're using text analysis tools, frequency analysis, collocation analyses to chart collocations of words that like to hang out together as history progresses through that century. So it's actually an interesting methodology, not just static, but what words evolve in frequency together over time, and what conclusions can you draw about the works and about society from that. The state of the art right now is topic modeling. So I'm going to show you an example. Do we know what topic modeling is here? It's machine learning a methodology. The idea is you treat all works as bags of loose words. And the hypothesis is that there ought to be deducible a discrete number of themes or topics that are responsible for generating the words in this particular body of text. So the holy grail here is to defer humanistic interpretation, to let the machine do a first pass of interpretation to suggest the themes that you should be interested in, rather than leap in right away with a theme you have in mind and look for the evidence to back that up. So this is an example. This is a topic modeling of the entire run of PMLA, the main journal of the Modern Language Association, journal articles over the last 100 years or so. Each of these are the top 5 words in a thematic cluster of words that the machine has found. Some of these make sense. So, for example, this topic is going to have to do with Irish literature of different kinds. If you click here, you see that these are the top words in that particular topic, and then you see what proportion that topic shows up in individual articles here. So it's a way of machine learning the structures you have to be looking at thematically in literature. I'm just going to be very quick now because I'm using up my time. The other great growth areas in digital humanities now is social network analysis. We're not doing anything sophisticated relative to what the social scientists invented these methods for doing. But just by way of an example, let me show you this. This is Franco Moretti's hand-drawn social network analysis of the characters in the play by Shakespeare, Hamlet. So right now, we're still stuck in modeling fictional societies inside worlds. I think the next step is going to calibrate that relative to the real world around these fictional works. So how does this compare to the court world in Shakespeare's time? We may not have the data, of course, that we need for that. So social network analysis, lots of people doing mapping work now. So especially in history, whoops, that's Cynthia's PowerPoint. So this is by the historian with the coolest intellectual name I've ever heard of. His name is Zephyr Frank. He's at Stanford in the Spatial History Project. Stanford is a big concentration of spatial historians. And here he's modeling the transitions in where the tinkers and other artisans in a Brazilian city are located across a particular centuries, drawing conclusions from it. So lots of mapping work going on in different ways. I'll show you another quick example. This is Franco Moretti, a little hand-drawn map of a set of village novels, as they were called in the 18th century, to reveal the fact that there's a circular pattern there, which is quite revelatory given what was happening with enclosure laws and roads and railroads at a particular time. One of the most state-of-the-art pieces of research I had got a chance to see recently is a digital humanist who's trying to find a computational way to generate maps from textual descriptions of geography. What can and cannot be done in terms of mapping based just on a novel describing geography, or it's a very interesting set of issues there. Media archaeology, I'm not going to go into detail there. That's the entire cluster of people who are interested in historical technologies from a contemporary media and visual perspective. So let's go back and look at what the typewriter enabled as a media instrument. Let's go back and look at what the telegraph enabled. Let's think that through from a contemporary theoretical perspective. And finally, what I mentioned earlier, critique and performance theory. I'll give you one example of that. Jerome McGann running a particular painting by Dante Gabriele Rossetti through Photoshop filters, one after another, to find the most disturbing effect that would reveal some hidden structure in the paintings that we had not seen before. Or again, he and Joanna Drucker running a magazine page from the 19th century through an OCR scanner 15 times to let the machine decipher what the interesting structures on the page are, both graphically and textually. Those are ways of not respecting the original structure and semantics of work, breaking it up, using glitch tools, another robust research area now in the arts and digital humanities, to discover new phenomena. I'll stop there.
Okay, and some of what I'm going to say is very close to what you're saying, and we'll talk about network analysis at one point. But it's interesting, the task was to talk about information technology research methods. And from a communication vantage point, that's a two-barrel question, because you can say we do research and communication about new technologies, but we also use technology to help us understand human communication, which in fact is now invariably part of the new technologies and the new media, so that we're doing both. So I'm going to sort of approach this from the hybrid way, by looking at the notion of communication. And I put up here, these are just some of the models, right? It's unimportant what they each are, but what I want you to do is get a flavor for, in communication, we have an amazing number of models, and some are interactive, some are linear. We teach all the different models. But what's important to recognize is when we want to think about new technologies, we need to think about that communication is an interactive process. Senders become receivers at the same time. People are both. They are not individual, even though some of these models may in fact be that way. Messages are always interpreted. They're always in line with context. So that when we think about it, we're thinking about who says what to whom and what channel with what effect, but it's not that nice little linear model. So when we think about communication and new technology, we have to be thinking about sources, receivers, the messages themselves, the interpretations, and so forth. So I took each of those aspects of our models, and I'm going to talk a little bit about a technology that we're using to help understand it. I've chosen 5 of them. I could have chosen many, many others. I'm just doing this as a sort of an example. So the first one is this. This is when we use new technology to study just basic ideas about communication. In our field, homophily is a big deal. You use homophily as a communicative mechanism that predicts a whole lot of things. It predicts whether or not people are going to be linked in a social network. It predicts whether they're going to be linked in a semantic network. It predicts not only who talks to whom, but who likes whom. So this is a set of studies using Magic Morph, which is this lovely technology that Jeremy Valenson, is anyone here from psychology? Okay, he's worked with Jim Blaskowitz, and he was here, and he is now up at Stanford in the Department of Communication. But he did these studies that was a new way of looking at the idea of homophily. The way we used to do it is we would take people and we would manipulate whether they thought they were similar or not. We'd say, you all did the same thing on a survey, and we put them together and watch how groups interact and see if thinking you were the same made any difference. We also did it by actually putting people who were homophilous in some ways. So there were all kinds of ways. What Jeremy did was, and you can see he had 2 different studies, he took people, subjects, and he had their photos, and he morphed the candidates. In one case it was for the governor of Florida, and for the other it was the presidential election. And he had people look at pictures, and one of the candidates, either Kerry or George Bush, or it was Charlie Crist or Jim Davis, looked more like the person. And guess what happened? People said they would vote for, regardless of if they were Democratic or Republican. control for all that, people in fact voted for the people that they felt were more like them, were more similar. So it's a very interesting way, and this work has now morphed into very many different things. He now has avatars that look like you, and he has, in his lab in Stanford, he has discovered that if you meet your old avatar in virtual space, you're more likely to report that you're going to save for old age. So he has some very interesting ways that the similarity of source affects us. So that's where we're using technology to simply look at a communicative mechanism that isn't necessarily itself. Okay, then we have, we don't have anything. Okay, we also have this notion of source and receivers, right? And so one of the big areas in communication that we've studied is deception. How do you know that people lie? And we've come through all these cues of doing it, and we've coded nonverbal behaviors. I coded nonverbal behaviors for my master's thesis. When I was asked, what did I learn most about my master's thesis? This was 1978. I said never to code nonverbal behavior again. I was doing it with, I had tapes and I had to stop it every 1/10 of a second and code it and go on and train people. Now we have all kinds of computer programs that enable us to do it. And Judy Burgoon at the University of Arizona and a bunch of her colleagues have developed all sorts of programs that take into account over 500 cues to be able to detect people's movements and to see, in fact, if they could find systematic ways that people nonverbally, as a source of communication, you can tell that they're lying. And they've worked a lot with Homeland Security, they've worked a lot with the Defense Department, as you can imagine. They have this interrogation bot, which scares me. In fact, it looks at your verbal cues, it looks at your visual, where you're looking, your hand movements, it looks at your body language, etc., and it is looking to see whether or not, when it tracks these movements, it can determine who is lying or not. These actually we used in Arizona in airports to check about people's movement. So there's some pretty frightening stuff about some of this, but it is the kind of a lot of research is being done. The other thing that they do, and this is someone named Nora Dunbar, who's at Oklahoma at the moment, they have this program called Macbeth, where they're using technology to train people to be able to determine if someone is lying or not. And it goes through a set of simulations and so forth. But all of these kinds of programs, and there are many of them, are decoding nonverbal behaviors, physical as well as eye contact, as well as voice, paralinguistic cues, to be able to make assessments between source and receiver. So that's another kind of work that we do. A third one now goes into sort of the network, because those are sources and receivers, but then of course messages from those models is the thing that is linking and bringing people together. And so I've taken two kinds of network analysis. There are many. Many of you probably are familiar in social science with UCINet, which is a network analysis that is basically who says what. It's who to who. It's a person, but now you can look at events, and it has ways of looking at the link. Does not have to be just two people talking. I have done in my own work semantic network analysis, where I have used as my link a shared interpretation between two people. So I was looking at workplace participation in Europe, and I was looking at Danish managers and from all over the world, and seeing if in fact culture was affecting how they were enacting the EU regulations on participation by a link being not they knew each other, they didn't, but a link being they shared the interpretation of what it meant. So there are many ways. This is an example. CRA is centering resonance analysis. It was developed by a colleague of ours in communication at Arizona State University, Steve Corman. And in this program, what you do is you are able to take text. It takes a lot of work to get the text in shape, but you can get your text into shape and it will do kinds of network analysis for you. And what's interesting about the text is you can use any kind of text. So the one that I've used as my example, and I just want to make sure I have it exactly right. The one that I use in the example is the fact that it was newspaper articles around two terrorist events. This was done by a graduate student in our department, Mary Dennis and Michael Stoll. And they were looking at the UK newspapers and the US newspapers on the basis of how did they frame these two terrorist events. And the terrorist events were the ones that happened in 05 and 06. It was the bombing on the London subways, and then the one that was stopped of the international terrorists. And so what they did is they took these analyses and they were able to look at the bombing, and rather than just doing hand-coded network, when you do analyses, you just sort of do a content analysis. They in fact put it through the semantic network program. And what the semantic network program looked at was three things. It looked at what were the influential words. And in network terms, those were the words of centrality. The words that were most central, and they used closeness centrality. So they came up with a measure of the most influential words. They then looked at what were the common words. And then they looked at how those words were in fact clustered together. So what you get is a map, as you can see, of what are the most influential words. The bigger the word, the more influential it is, and how they are linked in semantic space. What they found, which was really interesting, is that in fact, if you look at the UK newspapers, you have home, bombing, British, terrorist attack, country, Islamic, leader group. Look at the US. We have Muslim, Al-Qaeda, Iraq, terrorist world. What they found is that in the semantic space, the British press was identifying homegrown terrorism as the problem. Same event. The US was saying this is part of the international terror network. And each of the policies that occurred, you could track into the semantic space. So CRA is a way of looking thematically at how things are linked, and you just put the text in. And as long as it's written text, one of my graduate students, KK, was able to do her master's thesis on looking at the Citizens United case and looked at the actual court findings and their case and what was said, as well as the newspaper responses. And we found some very interesting different thematic ways that these things were handled. So this is one of our semantic ways. Another one is a network narrative analysis, and this is something Lance Bennett has done with Kristen Foote up at the University of Washington and Michael Timmons. And here what they did is rather than looking at text itself, they were looking at websites. And issue crawler is a way to map hyperlinks within a website. And so they were interested, again, in framing, but they were interested in the fair trade movement, and they were looking at different organizations that have certification. And their question was, communicatively, how were the kind of narratives that appear on the websites, how are they linked in the global environment, and what does that mean for the power of these certification programs? And so they did an analysis. They found the two organizations that were their seeds, and then they got through that, about 25 different seed organizations. They put that into Issue Crawler. Issue Crawler comes out of the University of Amsterdam. A man named Richard Rogers has done this. It's from they have a whole government program where they're looking at elections and all kinds of different kinds of texts. But Lance used it in this case. And what they found was, again, something that traditional content analysis or even kind of traditional semantic analysis wouldn't get at. They discovered that the UK's website and their certification was far less central. If you looked at their link within the network, people had other narratives. The whole space enabled multiple and diverse voices, whereas in the American one, we were very central, and there was a control of the kind of narratives. And so they used that in some very fascinating ways to predict what happens in real time. And in fact, the UK is a much stronger certification system than the one in the US, and they go back to these semantic spaces. So two different ways, one looking at the actual words and the text and getting semantic meaning. Another one is looking at what kinds of hyperlinks are within a website that create a narrative about a particular thing. So those are two. Another one that we have is called LIWC. L-I-W-C is pronounced LIWC. I'm not quite sure why, but that's what they say. And this is linguistic inquiry and word count. And this is a computerized text analysis. And it's a little bit different in the sense of the first two are looking at meanings and connections between things, and it's a network. In LIWC, they're looking at text as discrete items. So they're looking at word counts. They have a dictionary of certain kinds of words. They have, and let me just make sure I get them right, because there are many of them. So they have linguistic categories. You put a text in, the text could be a blog, the text could be a newspaper article, it could be a speech, it could be a play, any kind of text. They will look at the linguistic categories, how many articles, how many pronouns, and it literally gives you word counts. It gives you word counts on psychological categories of emotion. Is it a sad word? Is it a happy word? And they've spent years developing these dictionaries. It gives you the content categories. Is it talking about home? Is it talking about religion? So you get many different ways of categorizing. And what they look at is what is the effect of people using this kind of language. So some of the ones, and I've just picked two fun ones as my examples. One is the one about predicting success and failure in weight loss. And there what they did is they took the blogs of people who felt overweight, and there were all these blogs of I'm trying to lose weight. And they did a LIWC analysis on it. And they found that, and they did it over a year's time, and how much weight people lost was their outcome measure, because in communication effect, right, to what effect. And they found that the people who used very sad words, emotionally laden in a sad way, were, what do you think? More likely to lose weight. Wow. Than not. I know. That's why I wrote this down. And it's so counterintuitive.
Okay, so now why?
That, and they talk about in the article what they think is going on. And one of the things that this shows is you have to have a good theory to use the method, because the method itself is pretty atheoretical. It simply gives you a description. And they talk about, they've done all this work on the process of writing and how writing is cathartic and what it does and how it motivates people. So they go back to a writing model. But it is a really interesting one. But again, you need to have a theory in order to use it. The other one they found, which is I thought quite interesting, is they were looking at the whole notion of Craigslist. They were using that as a data source. And they were looking at ads from different cities in the country. And they were looking at what they call LSM, which is linguistic style matching. You can match two different texts and see if they match on the kind of pronouns they use, the emotion words, and so forth. So they have this LSM that they use in their studies. And what they found is you were able to see those most cohesive cities and those cities that weren't cohesive. You could not predict the cohesiveness, and that was again on these Craigslist ads that there were. And they were able to make determinations that it had nothing to do with race, it had nothing to, but it did have to do with the degree to which there was economic disparity versus economic, so that on the Gini measure, the farther apart there were the rich and they were more cohesive, interestingly, than less, because they found that only certain people were using the Craigslist. The rich people, forget it, they weren't, whereas in those cities where there was it, you had much greater. So they were looking at that. So those are just some of the kinds of things you can look at. Very briefly, the last one I want to talk about is one that I'm doing, and I haven't done it yet. But we know in communication we have verbal, we have the nonverbal, we also have visual communication. And I'm interested in social movements, and I've been very interested in issues of framing. And Shiv Ganesh and I have just had an article published from Wall Street to Wellington, which we look at the Occupy. And we can do all kinds of semantic network analysis, but we're also interested in some of the visual analysis. And this is a program, ImageDot, which I have all the information for you, which is a really fascinating program, because it lets us do stuff. It's part of the Natural Endowment for Humanities, the California Institute for Telecommunications and the Center for Research and Computing. And what they do is they enable you to do things that I never thought could happen before. And I'll give you an example. Theoretically, we know that in collective action, we have what we call the logic of collective action. We now have something called the logic of connective action, and we also have the logic of aggregation. And there are three different theoretical frameworks for how these protests happen and what the role of new technology is. So what we were interested in is looking at all the patterns of all the signs that occurred in Wellington. And these are just some of the pictures we took. And we started at 8:30 in the morning, and we have time for how these were and what they were. In just viewing them, we discovered something that we thought was quite interesting, but we had no way of analyzing it, okay? And that was the following. Scholars say that in this new form of connective action, people don't use the big frames that organizations always gave you. That now we individualize our frames, we create our own movements, and there's a whole part of entrepreneurial action that happens. People create frames that are much more personalized. In the logic of collective action, we say the organizations create these frames and people follow them. And then in the logic of aggregation, which is Juris, he says that coming together is where the frames happen. So there are three theoretical issues. And what we discovered, if you look at these frames, and I only have about 2 minutes left, so I'll go very quickly. If you look at the frames, some of them look just like they'd be in the US. Some of them look just like Wall Street, but some of them look very much Wellington. The one up front about how to vote out New Zealand's inside jobbers has to do with a scandal that was happening in Wellington at the moment. And so what we were looking at in this time frame, we wanted to know when they started, when people came to the Wellington protest, were they more personalized because they were coming at it? And as the day occurred, if you think about Wellington there, they were the first ones to have the Occupy. It went across the world. So throughout the day, people were texting and so forth. And over time, it seemed to us that the signs that they were making became more and more global, that they were getting tweets, that they were using all the different technologies. And it, in fact, was helping them shape what kinds of frames they were using for what Occupy meant. But we had no way of knowing that. So we found this really cool image plot, which we are now using. And what we're doing, this is an Obama State of the Union, his weekly addresses. What it lets you do is you can put any kind of visual in there. It breaks it up into frame by frame. It's a video. It breaks it up into shot by shot. It lets you get how many of different things. You notice they look at how many times there's windows or fireplaces or doors. It lets you look at tables, and it gives you when it's happening, and you look at the timeline. So what we're going to do is put our images in as communicative acts of frame and be able to look as the day went. We were there from 8 in the morning till midnight. Did, in fact, the frames change? And we will be able to do it using, rather than table and doors, we can look at physical as well as the actual messages. It lets you do tags. So I am really pro image plot at the moment. I have no idea. If I don't have, anything to report a year from now, I'll send you all a note it was a failure. But it's a new way of looking at our visual communication that we haven't done before for new technology. So that's it.
Thank you.
Thank you very much, first of all, for inviting me. So what I would like to talk about is a little bit different from the setup than what we heard from the two previous speakers. I'm glad that we have all mixes of styles. So I'm doing linked data, which is a specific kind of big data research, and I'm doing semantic web research, knowledge representation, which is very similar in terms of some of the methods you saw. In fact, a lot of my work deals with people working in the digital humanities, where we help them publish the data, semantically annotate the data, develop ontologies, so schemata to handle the data, use information, inferencing, and so deductive and inductive approaches to uncover latent trends, for instance, in the data, or enrich the data stores that they have. But for today's presentation, I thought that because the students are the audience here, I would like to show you work that actually my students finished just a few days ago, and I will try to walk you through why this may be interesting to you or what the methods are to do that. And I would like to talk about the point pulse system that we just developed and just published a paper about that. In fact, it's under review. So what is POI? POI is points of interest, and points of interest are just places of interest. So this is a place of interest, UCSB is a place of interest, a pub is a place of interest, an airport is a place of interest. But typically, we consider only things that are easily reduced to a point geometry as the representation. So California would typically not be a point of interest as such. You can think about that this way, but typically we don't. So one thing that caught the attention of many people in geographic information science, so the domain that I'm working in, was something released by Foursquare. Maybe some of you are familiar with Foursquare. It's like Facebook for people interested in sharing where they are. So people have, a smartphone application, and when they visit a certain place, they check in, that's the term for it there, and announce to their friends in the world that they are in this particular place, and then they can share their experience about the places, upload pictures, add the menu items in the place where they went, or for instance, like the place or whatever they want. And Foursquare is one of the biggest networks doing so. And they collect millions and millions of those check-in data, and sometimes, besides doing their commercial business that is making you the product, they also make some nice science behind that. In this case, it's an infographics, how they call it, about multi-millions of those check-ins aggregated over a full year, in this case in San Francisco, and they just want to show what they call a pulse of a city. So how is the city working based on all the check-in data that they have? And I would like to show you a video of that, namely here. Now I lost my controls. So you see the time of the day here, 9 a.m. You see San Francisco, you see different top-level categories like food, arts and entertainment, nightlife, great outdoors, shops and services, travel. And then you see, I hope you see that the resolution is pretty good of that screen, people moving into the town, that people right now are more in the night spot places because it's deep in the night. And then you see something very interesting here. Do you see that here? Not clear what's going on, but there's a moving food thing, and it seems to be very, very prominent. So that was pretty interesting for us, because there's this vision, or at least many of us have this vision of information observatories. So we have so much information out there now. In fact, the information universe, how we call that, is bigger than the physical universe, and we pride ourselves to be the astronomers of this information universe. So we want to understand what's going on there. Why is data the way it is? How is it distributed? What does the data reveal about things in the physical world and stuff like that? But you don't always have to bring it down to the physical world. Sometimes it's just interesting to study what's going on this universe of information, and I think we saw some great examples about that. So the problem with that, no matter how nice that looks, is that in fact we cannot do anything with it. I would really like to know what this moving blob was. That would be very interesting. It was very prominent. Keep in mind this is 1 year worth of check-ins, so we are talking something on the magnitude of some hundred of millions of check-ins here. There's something clearly going on there that you would like to know. So the problem with the video, and don't worry, you don't have to read all the text, it's more for your reference, is that the video is not enough. The video is not interactive, right? So you cannot click on anything there. Then this is recorded at a fixed geographic scale and for a fixed part of the city. You cannot pan, you cannot zoom in there and say, I would really like to know what's going on there, right? And unfortunately, they took all the millions of check-in data of a whole year and aggregated that into a single day. So this is like a virtual day, right? So you lose a lot of what we know from theory should make a huge impact. Weekdays versus weekends, it's not there. So whatever we see as a pattern, right? Sometimes people say that data should speak for its own. Well, we did a lot of research that way. Data doesn't speak, and there's no raw data. So data is always created for some specific purpose by some specific people using specific technologies. So breaking all the data, taking all the data for one single day shows some pattern, but you don't know whether this is any signal or it's noise or what's really going on here. Then they have 400 categories. It's incredible. They have Italian restaurants, Turkish restaurants, you have nightlife, pub, piano bar, hookup, whatever you can imagine, it's there. But then they generalize it to a very small set of 9 categories, which makes a lot of sense because you have to represent it somehow, right? You cannot draw 500 categories there, if not alone for the color ramp. But some of the decisions that they took, I'm not going to say they are wrong, but they are difficult to understand. So graveyard cemeteries, for instance, count as great outdoors. This is just one example, right? And this changes your pattern. If this is, a day where you would usually, go with your family to the graves of your grandparents, this will show up as, outdoors and entertainment or something like that, right? So maybe for some people, but most likely not for me. So we wanted to have a way to explore, to use some of the theories, how to structure points of interest that we are used to in science. And in cartography, we have a rich, theoretic background of how to split points of interest into types. We have the same for, many other parts, like transportation science, for instance, for urban spaces, to understand urban spaces. So how could you take the raw data from Foursquare and still come up with a categorization schema that is more informed by the theory so that we can use it in science? And finally, of course, this is all user-generated content, and I think you all know user-generated content is very biased, and typically, if you read a lot of papers, using that kind of data, they will somewhere in the introduction or the conclusions acknowledge, we know our data is biased, here's our work, right? And the funny thing is that if you dive deeper into that, then the data is so messy that, it's really difficult to make any meaningful statement besides, seeing artifacts of the data that you're using. So for instance, many people use this "my home is my castle" analogy to tag their own homes when they check into their own homes as castles. So this may give you the impression that there are many castles in LA, and we will show you a system of LA. It's not true. Then they also check into roads, trails, and taxis where it's not clear, what that really means, and whether this is a taxi stand or a moving cab or whatever this means. So it needs a little bit clearing of the data. So while this may seem to you like a pure criticism of the video, there's a lot of interesting science that you can do, acknowledging that such a city pulse, understanding how humans behave in a city, can reveal a lot of interesting work. So we came up with a set of 4 research questions. One of them is the one that I already mentioned. Given those 400 points of interest in Foursquare, is it possible to come up with an alternative top-level categorization, so those 9 level categories, that is informed by theory, like by the Ordnance and Survey of the UK schema, by schema.org, which is a very famous ontology by Google and Microsoft and Yahoo about points of interest, and still remain true to the original user behavior that manifests itself in this Foursquare data. So that's one question. Another question is that the real reason we expect why they do this video and nothing more is that, technologically speaking, even if you use the best and most modern browser technology, it's just more or less impossible to render that amount of data. We are talking here 200,000 points of interest, 4 million check-ins that we used, there are 24 hours in a day, there are 7 days in a week. So the pure amount of data that you have to process, and in fact it's highly dimensional data, each single data point has 246 dimensions, I'll talk about that in a second. So it's just impossible to render this in a browser. 2 years ago it would even be not dreamable to do something like that. Luckily the technology is improving so fast that there's hope left. So the research question for us, being information scientists, so always interested in the information aspect, but also the computability and engineering side of things, we thought, could we bridge together 2 radically different paradigms, namely image tiles, so loading images as a map, and loading vectors, so individual geometries, in a way that we can still show everything we want, still make it interactive the way we want, and still responsive enough to make this into a usable system. So research question 2 reads like, can you do the impossible? Which was an interesting task that made us cry many times and drink a lot of coffee. and I leave it for you to judge whether it worked out. So the third question, and this is one that I think is very interesting, also for, especially the sentient one that, doesn't let me sleep at night very well, is that there's a very strong imbalance these days between the research that certain, industry players are doing and able to do, Foursquare, Facebook, Google, and the papers they publish. I'm not sure whether you had the joy to review some of their papers. You can review the evaluation section, but they don't give you the data. So whatever they write in there, you just have to say these results look very impressive. So they sit on the data. It's data that you contributed, right? It's user-generated content. You check in and lose your privacy. You tweet something, but they don't give you the data back. You do it. They only earn your data, but they don't give you access to that. Luckily, they give you legal access to a small chunk of data. So for instance, you're allowed to crawl 5,000 check-ins events on Foursquare every day or hour, but you're not allowed to keep them longer than 24 hours, and you're not allowed to conflate them to any richer data set. So we had to do a lot of miracles to do what we did and still respect their API limits. Of course, most people don't respect their API limits, but then we would be in danger as soon as our paper gets published that we have to take it down. That would be kind of sad. So instead of having those millions of check-ins, we said, okay, let's be smart here, let's do theory and aggregate them to the type level. So we do what we call semantic signatures. We try to understand how people behave towards certain types of places. So pubs are only visited or mostly visited in the evenings, and not in just any evening, but typically in the evenings of the weekends. If you do the same for colleges, and some of us here can confirm that, colleges are mostly visited from like 7 a.m. to 6 p.m., mostly Monday to Thursday, and there's already a big drop on Friday, and we see that very clearly in our data. So we try to model the default behavior. So what I will show you in a couple of minutes is taking the same perspective as the system from Foursquare, what's going on in the city, what's the pulse of a city, but we are not taking data of each individual of those 200,000 points of interest in LA, but we generalize them to the type level. So all nightclubs, all hookah bars, all piano bars, and there are 400 of them, hospitals, police stations, and that allows us to stay in the API legal limits. And moreover, it's very interesting because we learn something about the types of places and the human behavior. But that leads to the question, can we also show real-time data? So if we zoom far into one region of the city, we can actually show what's going on there right now. And based on real data, not the default behavior of humans, players, maybe 10 or 20, it's sports. But for the 20,000 looking at that, it's most likely an attraction, right? So that's another interesting question to deal with. So what have we done to address that? Well, you have to do multiple steps, and this is where the research steps come in. First, you have to extract quite a big number of data, 200,000 points of interest in our case, 400 million check-ins. You're only allowed to get a very small number of them per day, so you have to split it up on many machines. In fact, we are running 100 machines on Amazon's cloud. You have to extract a huge number of features. I talk about that in a second. 246. So each point of interest is 246 dimensional, which makes it quite a big data set. So you have to think about which of those features is interesting. You have to find a theory, in this case schemata or ontologies about points of interest and how they are categorized in the literature to see whether you can come up with a more understandable way to structure the data. You have to understand which of the many characteristics you extracted is predictive, so you use machine learning technologies like you would compute the information gain that each specific feature adds to your classification. You would then also use, for instance, in our case, support vector machines, so a machine learning technique to predict class membership and also to understand the bias. I talk about that in a second. You would then also use that to have probabilistic models so that each class, each point type can be part or be a member in multiple of those top-level classes. And of course, you have to be willing not to stick with your theory, but to adapt it independent of the data that you have. And well, finally, you have to understand all those technological implications. So, this is all done as an overview of the data. So let me very briefly show you what we have. This what looks like the greater LA area as a map. is in fact those 200,000 individual points. They are so dense that you believe you can see streets or something like that. That's not the case, it's just 200,000 points of interest. So let me just show you one very typical example of a cafe or restaurant next door. If there's a police station here, you can bet there's no police station next door because hopefully they are regularly distributed in space to serve their needs like the hospitals. And finally, and this comes to the LDA, the topic modeling that you're also using, people leave reviews, leave tips about those places, so we use latent directly allocation, which is an unsupervised topic modeling technique to mine for certain topics. And what I find interesting, this topic is clearly a Spanish-speaking topic, right? There's a garden and flowers topic, and one that is about, city councils and stuff like that. This gives you another dimensions. Then you, of course, and I'm skipping a lot of step here, you would do information gain and information entropy to see which of them really matter. And finally, you would go out and look out for the theories that there are. So schema.org is the biggest ontology from Google and Microsoft that I mentioned that has restaurants and types of places, information about them. Here you see the ordnance and survey classification. This is like the British USGS, the US Geological Survey, and so forth. You would pick some of those categorization schemas, and then you would use machine learning techniques, to see how fit they are for your data. I have to accelerate a little bit, but I'm nearly finished anyway. And then, of course, you would do your machine learning classification. Here you see precision and recall values and a confusion matrix, and the information gain of multiple bands. You see the temporal dimensions work pretty well. And you see we are very good at knowing what will be an entertainment and nightlife place, not so good what would be public infrastructure. Let me make the last point of that slide. We also analyzed when to show raster and when to show vector types. So you see that showing images, this is the orange one, is fast at the beginning, but doesn't allow for user interaction. And then if you zoom in enough, the tiles, the individual geometries are so fast that we can really enable user interaction. This is again pretty big data, whatever you call big, but only for LA you have to cache in the background 12 million image tiles to serve to the users. And that's the end. Now you want to see the tool, and I have slides for the tool only in case I don't have an internet connection, which I hopefully have. The only problem with that is here's a early warning. This needs a lot of bandwidth, so I'm not sure how in the morning there's an increased activity in certain parts of the city. So this, as such, doesn't look maybe so interesting, so let me jump to the very same time to a more detailed part, and now you suddenly see all those top-level categories that you see here in. You can turn them on and you can turn them off, and you can also see now it's in the middle of the night, so you see a lot of the red dots over here and there, right? And if I would continue, you would see people finally go to sleep, and then in the morning you would see a lot of yellow showing up. Now it's recaching because the connections are fast enough, but you see that the colors are clearly changing, and now the retail places are opening and so forth. So we can also go into a more specific part of the city, and now we are changing to vector technology all seamlessly, which is quite impressive. Let me just reload that because this time early in the morning on the weekend there's not so much going on. Let me briefly redo that here in the night. So now you see we can now interact with each of those individual places and see a probabilistic model of the category name of the category membership. So this is a specific nightclub, this is a speakeasy, you have tons of them, and we can really see, you can go hour by hour, weekday by weekday, and see how the behavior, of the people towards the city changes.
Okay, so I will try and use the 10 minutes left and talk about what I wanted to talk. The things that I wanted to talk about were some of the research methods that we use from the perspective of different disciplines, at least for one dimension of the kinds of research that we do, looks more at hypothetical systems. That what we're trying to understand is behaviors that may happen, or we're trying to understand how, for example, different kinds of protocols will work in different kinds of settings. And you certainly can understand some of the challenges in trying to do that in the context of the internet. So a couple example, fairly bland examples compared to what we've already seen, but important nonetheless to computer science. So one is this idea of queuing systems. And so from a very simple perspective, you can look at the difference between how you line up at a bank versus how you line up at a grocery store. And you can use whether you have one line for each of the processors, or whether you have a common line and then everybody feeds into a set of processors. And another example might be packets into a router. And you might have different qualities of service for voice or for video or for data. Or you might have load at a Netflix router, so requests for movies that come in. And depending on where the movies are stored, you want to try and understand different ways of allocating resources. And so you're very much interested in testing different hypotheses in a hypothetical world. Now, the methodologies that we can bring to bear on these kinds of problems are things like analysis. You can use Mathematica, and you can say, well, people arrive into the bank at a uniform rate, which obviously we know is not true. People don't arrive every 30 seconds, or every 60 seconds, or 90 seconds. And so the assumptions that we make when we do these kinds of mathematical models tend to generate unrealistic scenarios. But sometimes it's useful to understand relationships of different variables. The idea that if you have more people coming into the bank than there are tellers, given the average amount of time that it takes to service a particular customer, then the queue is going to build up. It's an unstable system. And so you can look at different ways within communications technology and propose different algorithms for how to adapt to these kinds of circumstances. Another kind of methodology is to use simulation or to use emulation. Instead of these mathematical models for how people arrive, you can plug in data that you get from the real world and say, okay, how is Netflix going to respond? Where is the congestion pervading some of the other methods within computer science? If you want to propose a new protocol, one of the things that you can do is go out and measure it in the wild. Measure internet stability and routes that are taken, and then say, well, gosh, we've noticed some anomalous behavior. How can we fix that with a new version of the protocol? Then you can simulate the system as best as you can, argue that you've come up with a solution to these two anomalies that you've found, and then publish it in some particular way. Now, what's interesting about publications is there's different methodologies for how all of us disseminate our response. Certainly there's journals, or let's start with books. Something a little bit more real-time is journals, and something a little bit more real-time is conferences, and Alan's a little bit jealous that we get to do conferences. But even now within computer science, we have other kinds of metrics that we can use. You can publish prototypes. You can even publish data sets. And you go through a process of anonymizing the data sets, and it's so important to produce these data sets in an anonymized fashion that other researchers can use, that sometimes if they're well received, they're counted as publications and you measure their impact, and it can help you get tenure. If you prototype something or develop any one of these kinds of analysis tools, did you publish your analysis tool?
Yes, sure, it's all open source.
And so in your biobid, what you use to get tenure, you'll point to this piece of software that you generated as an artifact, and it counts almost as a publication. So the things that we're doing now, not only with the results that we're seeing, are certainly changing even within the academic space. Now, two additional dimensions worth talking about. One is obviously social media, and that's almost passé now that we have big data. But one of the things in the computer science perspective, if you think about measurement and then emulation and then building these hypothetical scenarios, is the extent to which you have additional data that you can use. So setting aside the issue of big data, think about computer scientists who tend to shy away from the light and groups and talking and discourse and some of these things. As you fold in other kinds of society, a change that makes things more efficient or more effective, and those are the kinds of questions that you then want to try and answer and come full circle about. So that's my shortened version. And you'll also notice a couple observations. If you pay attention to the methodology, right? So you start off with Alan, who has spent a lot of time. He doesn't do PowerPoint anymore. He does these fully interactive, sort of parallel presentations. Same thing with Cynthia. Sort of there's a little bit more PowerPoint, but then you pull in these other kinds of demonstrations. They're all immensely effective in their own ways, and then of course I eschew any sort of formal technology in doing my presentation. So that's the kind of thing that you get at UCSB when you talk about